guys. So today I want to just real quick, you're not going to have any work today or any work to do. I just really need you guys to kind of watch this video and kind of get an idea of this. We're going to talk about the imaginary unit and the complex number system. We are going to answer questions that were formerly unanswerable, and that's really kind of what the imaginary unit is all about. It's going to enable us to answer questions that we could not answer before. It actually opens up a whole another set of numbers that you guys didn't know about. And there's been clues hidden in questions throughout the years that you guys have probably totally ignored. If you guys remember, if we said, back in the day, we said, what is, if I said we have, was it y equals 2x plus 4, and I said, hey, what's the domain, right? And again, even if you don't remember the stuff, we sometimes we said all real numbers, and then this word right here is important because if we're saying all real numbers, why didn't we just say all numbers? Why didn't we just say, hey, every number I can plug into this function to make work? There's a reason that word was real, because if there's real numbers, then there's going to be non-real numbers, okay? And listen, I've heard some debate what a terrible name this is, because they do exist. They are actual. So we call them non-real numbers, complex numbers, and imaginary numbers. But to call them imaginary numbers is a little bit disingenuous, because they do exist. They're not just totally figments of our imagination. But the idea is that they don't exist on a coordinate plane. So here's where this gets a little bit different than what we've been doing, is that when we've been graphing things in the past, every number has fit in here somewhere, right? Whether it was a fraction, whether it was a decimal, whether it was, what do they call them? Things that don't end. Square root of 2. Oh my God, brain fart. Rational. If they're rational numbers, if they're irrational numbers, if they were big, if they were small, it didn't matter. They all fit nicely on a coordinate plane. They all fit on a number line. Your imaginary units don't exist on this plane of existence, okay? So, without further ado, let's talk about what exactly it is, okay, and how they're going to come to be, okay? So hopefully you read the little biography I sent you guys on Cardano, because he is one of the more interesting people. So if I said, hey, what's the square root of 9? You would tell me the square root of 9 was positive 3 or negative 3, right? And if I said, hey, what's the square root of 2? You would tell me that it's positive and negative 1.4, was it 414, I think? 41435, right? Going on and on and on and on, right? There were answers to these problems. If I said, hey, what's the square root of, I don't know, what's another, 18, right? Well, you guys knew we could break that down. We could say that was radical 9 and radical 2, and that was 3, radical 2. They were answers. If I said, what was the square root of 0? You told me it was 0. If I said, what was the square root of 100? You told me the square root of 100 was positive or negative 10. And then if I said, hey, what was the square root of negative 4? You tell me, I don't know. There's no answer to that, right? There is no answer to the square root of negative 4, right? You go in your calculator, you turn it on, you say, hey, what's the square root of negative 4? And your calculator will tell you it's a non-real answer. Okay, in other words, your calculator does not have an answer for this. It is a non-real answer. Okay, so non-real numbers, imaginary numbers, and complex numbers, all in the same kind of family of things, all have to do with this idea that there is no square roots of negative numbers, right? But what if I said this? Well, the problem is that you hit a roadblock, that there is an answer to this. The answer to this is, for sure, -9, right? The answer for sure is -9. We know that squares and square roots undo each other, right? But the problem is that you can't actually evaluate this inside. This number doesn't exist, right? But we know that if we square, like that number, we know that squares and square roots undo each other. So imaginary numbers are going to help us answer the questions that were formerly unanswerable. So I don't even know if your calculator does. Let's see if it'll do it. Let's take the square root of -9 squared. Let's see if your calculator will do it. No, it won't do it. And so, again, there is an answer. We know that squares and square roots undo each other. There should be an answer to this. It should be -9. So let's talk about it. Let's get right into the swing of things. I need to get a different thing focused because this is too shiny. Hold on. Okay, sorry about that. So let's get right into it. So what is the imaginary number? Okay, very simply, defined is this way. If I said, hey, what is the square root of -1? That is I, the imaginary unit. Now, I'm the last person who should be telling you guys about handwriting, okay? But it is not I. It is I, okay? Little fancy italicized I, okay? Again, I, not I, okay? So if you guys are wondering why you don't see I as a variable, right? Think about this. If you were doing any kind of proper math in the last, 8 or 9 years, 6, 7 years since you've been doing variables, 3 or 4 years for some of you guys, you've never seen I as a variable. And if you have, it was a very basic level of variables. We don't use I as a variable. And the reason is because I is the imaginary unit. It's a specific definition in math, okay? To just differentiate in case there was any type of variable, we write it as like this italicized kind of script I, okay? So that is the imaginary unit. So if I said, hey, what's the square root of -1? It is I, okay? That gives us a way to answer this problem, okay? All right. So let's just talk about that. Right in itself, this is the one thing you need to know coming out. Square root of -1 is I. It is the imaginary unit, okay? So what if I said, what's the square root of -9? Let's take it back to that question we had. Well, you guys know I'm allowed to split this up. What if I said this is the square root of -1 times the square root of 9? Well, the square root of 9 is 3. And I just told you this, the square root of -1 is I. Okay? So if I said, hey, what is the square root of -9? It is, you put the number first, you put the imaginary unit second. It is 3I. Okay? So again, this will allow us to go ahead and perform operations, to do things with numbers like this, okay? So real quick today, what's the square root of -49? Well, again, let's break this down. That would be the square root of 7 times this, the square root of 49, getting ahead of myself. Square root of 49 times the square root of -1. Well, the square root of 49 is 7. Square root of -1, I. Okay? So it just, all we need to do is separate out that negative. If I said, hey, what's the square root of -100? Break it down, just like we were doing last week. That's the square root of 100 times the square root of -1, because 100 times -1, -100. Square root of 100 is 10. Square root of -1, I. Okay? If we got things like the ones we've been looking at, things where they're a little more complicated. So what if I said the square root of, let's go with that example we talked about before. What is the square root of -18? Well, the first thing you want to do before you do anything, get that I out of there. Square root of 18, square root of -1. This problem is the same thing we've been doing all week, right? So let's break this down. What is this? This is the square root of 9 times the square root of 2 times the square root of -1. Square root of 9 is 3. Square root of 2 is the square root of 2. And the square root of -1 is I. Just by definition, it is I. So what we say this is 3I times the square root of 2. That's it. Okay, so the only thing we're adding is it. All you have to do is when there's a negative, take it out, and we're going to go ahead and we're going to call that the imaginary unit I. Okay? When we write imaginary numbers, if there's addition or subtraction, just a quick little intro, we always write them A plus BI form. Okay? In other words, if you have regular numbers like 5, and you had something like this, like 3I, okay? It always comes last. Your imaginary numbers come last in the hierarchy of things, okay? So we don't say 3I plus 5, we say 5 plus 3I, okay? So we'll talk about that next week, okay? But really, this is the only thing that's new today. So again, no new work today, just the idea of this, okay? That the square root of -1 is I. Why? Because it will allow us to answer questions that we could not answer before. Okay? Thank you. That's it. Have a nice day.